So this is a quick video to show you how to screen for anomalies in your data in a really precise and methodological way. So the first thing I'm going to show you before we start the video is this slide here. So I think it's slide number 34. If you think back to standard deviation, what we said, if I zoom in, is that we've got the mean of a data set, and then we find a lot of our data in normally distributed data is within one standard deviation. So if you were to plus or minus the standard deviation from the mean, you should find a lot of the data falls within that range. The same can be said, even more data falls within plus minus 2 standard deviations. So this is this part here and this part here. Anything that lies beyond 2 standard deviations, i.e. these little tails of data here, we can definitely consider to be skewing the rest of the data. It's really extreme, like probably an anomalous result. So these are the instructions. You can have a little look if you want to press pause, and you can read the instructions here. Otherwise, I'm going to show you an application of this in a real data set. So I've just sampled one of your data sets. I'm going to show you where we go. So you can see here that this is the data that we want to be focusing on because it's actually got 5 trials, more than 5 trials, it's got 6. So we're going to make it blue. This is where I'm going to work. We've already got the mean and the standard deviation, so this is what we do. We insert a column to the right. In fact, we insert quite a few columns. And you can obviously see how I've done that. Feel free to go back. We're going to work out what 2SD is. We're going to add 2SD, so we can do, let's have a look, plus 2SD, or plus 2SD just for now, just to get that to work. And we can do minus 2SD, and we're going to do that from the mean. So here we go, equals sum, this times 2, close brackets, and then it automatically does all of these for us. So that's great. This is really important. This is a key statistic. What it tells us is that for this person, participant number 1, it tells us that his standard deviation when he was doing this data is this number. If we double that standard deviation, what we want to be able to do is actually then find out if he had any data that was above or beyond this normal amount. So let's have a look at how we do that. Obviously it did it automatically here. If it hadn't have done that, we can just drag it down and we get the same effect. So let's have a look. Plus 2 standard deviation. So equals sum. We're going to click on the mean and we're going to plus our 2SD, close bracket. We can accept that suggestion. We're going to do the same thing here. Equals sum, select the mean, and we're going to minus those 2SDs. Now what we've got is a range to work from. So if I look at this person's data, I'm just going to highlight it yellow so it's really easy for me to see. If any of that person's values are above this number or below this number, what we're saying is that that's going to be an anomalous result. All right. I need to check that. So let's have a look. Do we have anything that's above 1200? No, we don't. Do we have anything that's below 242? No, we don't. So this person is now clear. We could maybe change that to green. We've screened it. There's no issues. We go back to blue. We need to do that for every single person. And what you will find is that you can identify in a data set anomalous data using this method. The other thing you can do, and what I would be looking at for sure, and we've done this in class together, is we know that standard deviation, the bigger the number, the bigger it is, the more variance around the mean. So if I go back to this, the bigger the standard deviation, the more spread away from the mean that data is. So let's have a look. Let's have a look at that in action. That number's really big, this number's really big. Straight away, I might be thinking I want to have a look at those data sets a bit more closely. Is there a value within there that looks different to the rest? This is quite a small number, quite a big number. And again, I don't think we've got any others that are maybe too concerning, but that method that I've just shown you will actually help you to identify any like definite anomalies that are beyond that range of about 95% of the data. So only 5%, more or less, will fall beyond this range, but it is definitely anomalous and it will be skewing the data. Let's have a look. What you could do then when you've identified large standard deviations like that is I would be looking at their data, comparing it to the mean, comparing it to the standard deviation, and just seeing if there's anything that looks a little bit amiss. For example, straight away in this data set, I'm going to highlight that one red, and I think that is an anomalous result, so I'm going to check it against the ranges. It's really, really small compared to their mean result, but also compared to their other values. If I were to extend this data processing, I would actually add another column here, and I would add max just to test that theory. So max result is going to look at all 6, close bracket, and it will tell you the maximum value. That's them performing at their maximal. And remember, if you're doing a maximum test, that is kind of an important statistic to refer to as well. So this person's data here, look at their max value. It's nearly 900 newtons. This person has then performed at 339, and everything else is closer to 800, 700, and 600s when they were first starting. I think that is an anomaly, and I would actually remove that from processing. So what I would say underneath the table is something like this. Red values indicate anomalous results. And then I would actually say underneath here, participant number, who's this? Participant 6. Trial number 5 was removed from processing because. And then you need to justify why you've chosen to remove that value. It doesn't actually fall below their 2SD range. It is within the range because it's above 297. However, we know that it's really, really far away from their maximal result, and everything else is above 630. That appears to be a very strange value, so it's justified that we take it out. You need to screen your data in the exact same way.